I welcome Andrey Lukyanenko for this podcast, who is an data scientist, who is also an Kaggle notebook grandmaster, and also he is one of the best engineers that I've seen in the Kaggle today. Why? It's because I've seen lot and lot of notebooks and lot of work which has been done in Kaggle. At the end of the day, proper tailored work which has been given out to the world in order to give it proper understanding of what kernels are all about. And he was also a discussion grandmaster. So it gives me an immense pleasure to do my podcast with a two-time grandmaster Andrei Lukyanenko in my channel. Thank you so much, sir, for giving me this podcast.
Greetings, hello, and thank you for inviting me. I'm glad to talk on your podcast, and I'm really glad that you like my kernels. Thank you.
Yeah, thank you so much, sir. Then let's just jump into the questions then.
Sure.
you know uh, I've been told in lot and lot of ways that machines are being trained to make decisions today. That's what all the data science lectures say you the same thing. Whether you do the nano degree or the Coursera course, they are teaching you how to get the insights from the data at the end of the day. I just wanted to ask you this one question: what's that most romantic journey that you had in the data science field? As a deep learning engineer, also you have worked in the Kaggle community. So what was that journey all about to you when you were endeavoring all these things which was in the field of machine learning, deep learning, computer vision, and also what was that all about?
Well, I think there were a lot of interesting things in machine learning, and as many people, when I wanted to become data scientist, I was inspired by these awesome videos of some interesting applications of machine learning and, not artificial intelligence, but some advanced techniques in the field. I suppose nowadays the most interesting things for me are about generating some kind of content and not simply generating it from scratch, but generating it based on something, because making some kind of recurrent neural nets which will create some random piece of text is cool, but it's quite easy to do. But if you can make a text in some certain style, like some kind of popular also, or maybe if you can make voice speech synthesis to generate a voice of some certain person, or create a picture based on some style, I think that this is really amazing, and this is really interesting, but at the same dangerous, because deepfakes are appearing, they appear more and more, and they are quite dangerous, but still I think that the technology is amazing.
I just wanted to ask you this one question because when I see your kernel, you have worked on deep learning and other technologies like computer vision and also some NLP or so. And also, you are also one of those person that I follow. Your kernels are on predicting the behavior of the molecules and also other data sets which I've seen. It gives me an immense pleasure to see your data set, how the way you have written the kernels. I just wanted to ask you this one question. You have worked on computer vision and other technologies. Which is the most fascinating technology that you have come across, and the most beautiful concept that you have also learned through that technology?
Well, let's see. I suppose this is somewhat similar to the previous question, but I think that nowadays, if we talk about some kind of technology, then for me it could be about either huge text transformers, or maybe about some advanced GAN architectures, because transformers they were a breakthrough. I suppose a lot of people remember that. And while there are somewhat overrated, and that by overrated I mean that GPT-3, which is quite popular, well, in fact, it simply learned based on a huge amount of text, and it still makes a lot of mistakes, a lot of errors, and it's simply most of cool predictions are simply based on the things which it memorized. But still, that technology which allowed it and promoted it and made many other things possible is fascinating to me. And there are a lot of smaller research into transformers working with longer sequences, being more efficient, being faster, and so on. And I hope that in future we will have more architectures which will be much smaller than current huge models and will still work well. And as for guns, well, this is just fun because you train the model on images, you can generate new images. They can be random pictures and can be based on some style. And I think this is quite cool. There are many sites like this shot doesn't exist, this something doesn't exist, which show quite realistic photos which were generated by guns. And I think this is quite cool, and maybe it will be more applied in future for some real purpose.
Yeah, I just wanted to ask you this one question. How has Kaggle influenced your career at the end of the day? When you look back and see your work, how has been that journey, and also how has it been that influence in your career today?
Well, I think I can't thank Kaggle enough because Kaggle made most of my career. At first, it wasn't very useful for me. It became more useful after some time. Let me explain. I have started learning data science in 2016, so more than 4 years ago. And at first, I went through Andrey course on machine learning. I studied Python. I started working with Titanic dataset on Kaggle, and as many people. But when I started looking for a job, I have realized that my skills aren't good enough at all. That Kaggle is nice, but it can't help me to get the first job because I need some practical skills, pure practical skills like SQL, like basic machine learning approaches, like statistics, and many other things. So it took me 8 months to get my first job, and I spent this time on acquiring basic skills. And even after I started working, I have spent more than a year on acquiring some skills outside of Kaggle. For example, I have made a small website where people could draw some numbers and the models will recognize them. It was very far from Kaggle, but it was totally about the job because it was about making a project from scratch till the end, collecting the data, making website, training models, making the predictions, making website work online, and so on. It was quite important for job, but well, it weren't skills which would be quite cool in Kaggle. But after some time, I think it was in 2019, I decided to return to Kaggle because it is fun and a lot of people which I respected took part in Kaggle and encouraged other people to do it. So I have started slowly. I started taking part in competitions. Often I failed. Sometimes I got bronze medals, for example, and was very excited about it. And somewhere at the time, I wanted to compare my analytical skills to other people's. So I started writing kernels. First kernels weren't very good and weren't up to current standards. But I have learned from my mistakes and tried to improve my work, tried to understand how should I write the code, what is interesting to people. And after some time, I got quite good progress. And not only I got recognition, but I really got skills because if you know what it is about writing kernels fast, it's about creating my minimum viable product very fast. And it's especially difficult if you are working with some kind of new domain. You either wait for other people to write kernels on this part, or you go to internet and try to find some blog posts, some papers, something about the task, and it can be quite challenging to do it fast enough. Well, nowadays people usually spend maybe 1 or 2 hours, and then already there are new kernels on the new competitions which are quite good. So I learned a lot of skills, and after some time, I got my ranks. I became discussion grandmaster. I got first rank in kernels, and was more important, and became competition master. And these achievements allowed me to find new and better work faster. They allowed me to get recognition. They also allowed me to get some soft skills like communication with other people's, formulating my thoughts better, and so on. So I think Kaggle was amazing, but at the same time, it's important to understand that there are other skills which are necessary at work, which Kaggle doesn't. provide. But the things which you can learn at Kaggle, they are amazing and help a lot.
I just wanted to ask you this one question because you have seen the industry flow without TensorFlow also. But I feel as soon as the TensorFlow was open sourced, it really changed the game of technology, according to me. What was the actual situation when there was no TensorFlow in the world?
Well, I can't talk from my experience because when TensorFlow appeared, I wasn't working in data science and I wasn't working with deep learning. So, as far as I know, while TensorFlow was great, it wasn't the only framework on the market. And if we talk about neural nets in general, people worked with neural networks long, long ago. They were basic, they were slow, but they existed. And even at the time when TensorFlow appeared, there were multiple tools like Theano, Torch, MATLAB, Chainer, Carfres. There were a lot of libraries for deep learning. They worked. So Kaggle had a lot of competition, not Kaggle, TensorFlow. But I suppose it proves that it was quite efficient. And nowadays, I suppose, one of the two main frameworks for deep learning. So it had a lot of competitors at the beginning, but it defeated most of them.
Yeah, I just wanted to ask you this one question because what's the most beautiful concept of machine learning that you have come across? We have GANs, we have deep image priors, and also you can also say about the most beautiful concept which you have come across in mathematics that also can be answered. Like I just wanted to give that understanding for the people about whether the concepts are really good enough to just get your first job or be the Kaggle grandmaster, or else you need to put some more work. What's that all about?
I think these are really different things because concepts are nice, but you need to have practical experience. If we talk about concepts, I suppose for a long time I was fascinated with style transfer. There was that famous work about Starry Night and how we can change the picture to some other appearance. I have also trained models to do this, and it was really fun. And I remember that I also did it while going through Stanford course CS 231N. It was tough at the time because at the time TensorFlow and PyTorch were very young and syntaxes and API were quite difficult to work with, but it was very fascinating for me and interesting. But sadly, to get a real job, this isn't really enough because if you know some beautiful concepts but haven't worked with them, then well, you wouldn't be able to do it in your job the fast. You would need to learn how to do it in practice. And well, the sad truth is that a lot of companies don't work with beautiful concepts. They need to do something valuable which can bring money. And so I suppose most data scientists don't work with deep learning. They work with tabular data. They make churn predictions. They predict some products which will customers buy and so on. So one of the most important tools is the knowledge of SQL, for example, not the knowledge of deep learning. So, but of course, if you are determined, if you really want to do it, and if you spend enough time, you will be able to get the job in deep learning. But well, it's very tough to do it at the very beginning.
I know. I just wanted to ask you this one question because your your great notebooks have given a lot and lot of insights on how to write the best kernel in the world. I'm not joking because I have friends who literally follow your work because they love your notebooks. I just wanted to ask you this one question on how to approach a problem statement. What's the actual influence which you got from writing such great notebooks at the end of the day? When you're a Kagler, when you have a full-time job, how has been that influence of working for the community and working for an day? How has it made that influence in your life at the end of the day?
Well, let's see. First of all, it's important to understand that there are many different types of notebooks, and often they can't really be compared to each other. Because, for example, if you can write a notebook with a very good score, it doesn't have to have any plots. It doesn't have to have some good code. It does. It just has one target to have the best score, and many people will like it. And nowadays, so even there are many notebooks which simply blend predictions of other notebooks and still get a lot of upvotes. Well, I suppose this works for some people, but this isn't very cool. Some other interesting approaches for writing notebooks for example, writing some kind of tutorial to explain how machine learning algorithm works, how some library works, how to approach some kind of new problem, and so on. And most notebooks which I write, they combine exploratory data analysis, some kind of feature engineering, and modeling, so that you can have understanding of the data, trying to do something additional with it, and training machine learning models. And so, if we talk about writing better and how to write good and even better kernels, first of all, you need to learn from study from other people. So you read a lot of notebooks from other people and think which ideas you could borrow. It could be some specific code, or it could be some broad approaches to training models, or even more broad approaches to writing notebooks in general. For example, you could follow the main you could create the similar parts of the notebooks, or you can just follow the style of the notebook and create your own style. So at the beginning, if you are only starting to write kernels, it's a good idea to start simple. You load the data, you have a look at it, you try to make some plots, you add your own analysis. So the key here is to try finding something interesting in the data which is interesting to you and could be interesting to other people, and try to dissect it, to find more about it, to get some insights from it, and to find something which could be used based on it. After some time, it's also a good idea not to work with single variables, but make interactions between two, three, or more variables. This way, you will be able to generate even better insights and make some interesting plots based on this information. Then you could start creating features because, tell the truth, feature engineering for tabular data is often much more important than the selection of the model. Well, of course, if you choose between, for example, logistic regression and gradient boosting will be better. But if you want to spend, for example, 5 hours on something, it's much better to spend these hours on feature engineering than on tuning hyperparameters, because hyperparameters will give some little impact, but some kind of domain-based features will have an amazing result. Of course, also you need to train the model by itself, and also it would be a good idea to explain predictions, to use some kind of tool for interpreting feature importances like sharp or lime or LF5. Maybe plot the distribution of predictions and so on. So the main idea is to generate some new content, to explain it, and to make it available to other people. I suppose that's it, the main gist of it.
Yeah, because when we have to learn new frameworks, we actually don't get good amount of documentation sometimes, or else we might not get the good amount of community support which is there. But I just wanted to ask you this one question: what is the hack in order to learn the new framework or the technology? Is learning new technology good enough to make our life easier?
I suppose we need to define what the technology is. For example, technology could be like a new library, which is a wrapper over scikit-learn, for example, or it could be a new framework for deploying, or maybe it's a big technology like self-driving cars, right? So it's difficult to classify them and talk about all of them at once. I think the main idea is not to start learning new technologies blindly, because every day new paper appear on the archive, every day new repositories on GitHub appear. You simply can't learn everything, even if you want. You simply won't have enough time. So I suppose it's good to have T-shaped skills, like you learn some small, many different things, but with a shallow understanding, and you choose several things which you want to know deeper, deeper, and deeper. There is some kind of Pareto rule: is if you spend 20% of effort, you could get the 80% of the total result. So the suggestion is decide whether it's worth learning the new technology. For example, you could make the decision based on your interest in the subject, of the relevance of the subject to you, maybe its utility, maybe its popularity. And as for how to learn it, well, I suppose usually there are no simple hacks. If there is some tutorial or blog post somewhere discussing this technology, use it, of course, and try to learn from it. If there is no information as technology is completely new, I suppose the only way is to load this, for example, library to explore every function, every class, every method where in it and try everything by yourself. It will take a lot of time, but you will know everything about it, I suppose, something like that.
Yeah, I just wanted to ask you this one question. What were the technical constraints that you faced during your project initially, when you were during the initial days, when you were writing kernels, or else probably during your work? And how is it different these days? There are lot and lot of wrappers available. There are cloud support which is available. And what's the difference that you faced during your initial days, and what's the difference that is today with that association?
That's that's quite a great question. Let's see. I suppose at the beginning the main problem was the lack of experience and the lack of knowledge because even if you got the first job, often, well, not often, always, you don't know enough because there are lots of things which you need to learn. A lot of them are specific to the job, and if they're specific to the job, well, you just won't be able to learn it otherwise. So the main problem in work and in my personal projects was lack of experience. Also, at my personal projects, one of problems was the lack of good hardware, because for maybe a year when I started to data science, I had a computer with 4 gigabytes of RAM and no video card. And it took me more than a year to buy a better computer, so it was quite difficult. And I remember that I simply couldn't work with certain data sets because I didn't have enough RAM. But nowadays I have different problems. For example, at work, usually the main problems are about the data, the infrastructure, and dealing with people. Because even if you know some cool machine learning techniques, if you know how to work them and have experience working with them, if you have no data, you simply can't use these models. And you need to get data in some way. Sometimes it's easier, sometimes it's difficult, sometimes you need to do it by yourself to get the data somewhere. And dealing with people is really important because the longer you work, the more experience you have, the more you are expected to talk with business people, you are expected to manage other people, to help them. So you need to be good at communications, and this is I suppose on the one hand it's a basic skill, but on the other hand there are a lot of people who struggle with it, and so you have to be better in it. As for my personal projects, I suppose nowadays I have too many things which I want to do and not have enough time. So it's painful, but I have to choose one of the or two things from all the things which I want to do. And it's also quite difficult to maintain life work balance, especially if you take into account self study time. Yes.
I just wanted to ask you this one question because you talked about experience. I just wanted to ask you this one question. Is just experience of problem solving good enough to solve the problems in machine learning today? Because there's a huge difference between what data sets were exactly 2 years before to me itself. Because when we were working on prediction algorithms, there were data sets for, okay, Boston housing data set, and all these were some of the open source data sets which we could have worked on. But today, when we see genomics is coming up into the picture, proteinomics on the other side, and there is a huge disruption in the field, which we never thought data science could be indulged and problems can be solved using it. And is it really good enough that you have some experience in solving problems? Is it really going to help us in solving problems today at the end when you're thrown out with some sort of a data set? What's that all about?
I suppose there are two different sides of this problem. First of all, suppose that you have some domain experience, but you have little knowledge of machine learning, and you need to solve some kind of specific problems. Uh, Often it's good enough because there are a lot of problems where you don't need machine learning itself, because if you have the data, maybe some basic analytics are already good enough to make some value for business. If we talk about some advanced problems when you need advanced machine learning, well, I suppose the main question here is whether there are some experienced people out there, whether there are some published blog posts, some published approaches, and so on. Because even if you don't have experience with this specific problem, but you have experience with many other machine learning problems, then you will likely be able to learn this fast and do it quite well. But there is also another question about how good do you need to be at solving this problem. For example, if you work on some, if you have a new task that you need to do some, it doesn't matter which, but some kind of machine learning problem, and it is required to have, like say, 99% accuracy or some other metric. I mean, there's a very high value of the metric. It it's really possible that this isn't possible because either data isn't good enough or machine learning algorithms nowadays are not good enough. In this case, then it's possible that this new problem isn't solvable using current technologies. It may be solvable in future, but not now.
I've been seeing a lot of your community meetup videos, or open data science community and other communities. You have been part of it, but I just wanted to ask you this one question: how has teaching in community influenced for the research? I know you don't teach there, but you help solve problem statements through your kernels, through your talks. At the end of the day, I just wanted to ask you this one question: how has been that influence of uh, helping the community out in some way has been an influence in your life and your career?
I think the main influence is that it helped me gain some additional experience. But first of all, why Kaggle is interesting? Because it allows you to take part in some projects which you will never work on at your job. Because at a job you could be doing some specific problems or maybe many problems, but Kaggle allows you to take part in many competitions with different domains, different types of problems, and so on. And so when I help some people with their specific problems, I face this new problem and have to think about it. And this helps me gain some additional experience. And also when I explain some things in my talks or maybe in my kernels, often I have to formulate my thoughts better and think more about the problem from basics. And it helps me to hone my basic understanding, basic skills. And this in turn improves my advanced knowledge. So it's quite useful, and I like it.
I just wanted to ask you this one question based on AGI, because AGI is the new buzzword today. Of course, there was a trend where deep learning, machine learning used to be the buzzword, but today everybody in the community knows it because it's an workflow of the community at the end of the day, because a lot of people are in. I just wanted to ask you this one question: how to build an AGI?
Well, if I knew, I would already do it. Let's see. There are two types of AGI. First one is weak AGI, when this AGI should be able to do some certain task, and it already exists. Our deep learning models already can solve certain tasks often better than people. So it's exists. But if we talk about strong AGI, some real artificial intelligence, then I'm one of those people who think that this is totally impossible at our level of technologies. Currently, our models, they don't think. You could say that any machine learning or deep learning model is simply some kind of statistics. They take the data, they train the neurons, for example, for in case of neural nets, they simply try to find the best ways for these data sets. So it's kind of feed into statistics. They can't think by themselves because there is nothing in neural net architecture which would allow them to think. So if we want to build the real AGI, we need some totally new approaches, totally different approaches from the things which we not do. because even if we improve the efficiency of computations, if we improve the capacity of our models, then fundamentally they still will be the same. They won't have some kind of intellect, sadly. But I'm looking forward for it.
I just wanted to ask you this one because, of course, we are on the verge of building AGI, but we are not that successful enough to give what strong AGI is all about to the world. But I just wanted to ask you this one question. What will be the questions that an AGI can answer if it's get built tomorrow? What are all those questions which we can really expect AGI to answer at the end of the day?
Well, the most important question of the universe, I suppose, from the cheaters guys to galaxy. Well, I suppose it's difficult to say because there is no some kind of single definition of AGI, and one more point is, will it be clever than humanity in general or not? Because if it has the same way of thinking as humanity, then it, I'm not sure it will be able to answer some questions which we can't ask. Uh, but if it will have some different way of thinking, maybe we want to we will be able to understand the universe in some different way, which would help us to develop technologies, to develop our way of life, to develop many new things which we can't even think about right now. The main difficulty in answering this question is because we don't even know what is strong AGI, so we don't know what it's capable of. So we don't know yet what questions we should ask it, I think.
There is an difference in practical approach and the theoretical approach every single day. When you read papers, it's just the gist of what their work is. So I just wanted to ask you this question. Is theory different from practical application with respect to TensorFlow?
I think it's completely different, and there are several, I suppose, types of theory. Yes, it could be theory of, for example, simply theory of using TensorFlow, but often people use frameworks in the ways which they weren't expected to do, and still it works. Yes, another idea would be it's the theory of deep learning, and then we could say that's totally different because there is some theory in, for example, how batch normalization works, how convolutional neural nets work, how transformers work. But if you simply know the theory, you won't be able to implement it in coding unless you know how to work in this particular framework. And it's especially problematic for papers when there are papers, for example, on Archive without any code. You could read the paper, you could understand everything, but only knowing what the paper is about won't allow you to write the full implementation in TensorFlow so that it will work as it's described. So I think that theory is very different from applications. They are connected, but they aren't equivalent at all.
Yeah, which is the best and the worst project that you have worked on till date? Because
Till date.
there are a lot and lot of projects which I have seen in your kernels. Yeah, even in your discussions, you actually give references to some kernels sometimes, or else you will actually tend to solve the problem through some or the other way. What's the best and the worst project that you have worked on till date?
I suppose one of the worst projects was in one small startup company where I worked for 2 months. It was the worst because there was very little data, there were very unclear expectations, there was bad infrastructure. Wasn't taught how to do the things right. There were a lot of mismanagement and miscommunications, so it was quite painful to work. And for the best, I suppose it was competition predicting molecular properties in Kaggle, where I got my gold medal in competitions. It was interesting because at the time it was, I think, the first competition where people had to use graph neural networks to have a higher score. And it was really fun because I started working with basic approaches like training XGBoost on basic features. Then I have improved feature engineering and start going deeper and deeper. After some time, it became possible to create a very interesting and experienced team, and we started to working with graph approaches. So it was really fun and interesting, and it was amazing experience of working with another people who were much more experienced than me.
Yeah, is hardware robust enough to or sturdy enough to run the algorithms these days? Because hardware is something which is more different because hardware is the new trend which we are working. Of course, there was an age where people were dependent on API, but today it's hardware. I just wanted to ask you this: is hardware robust for the algorithm these days?
I think yes. Currently, it's possible to train a lot of neural network architectures on simple video cards. You don't need the best and biggest card. For example, you could use 1080 or maybe even 1060 to train some models. Of course, you won't be able to train BERT from scratch, but maybe you will be able. But it would take some weeks. But still, it's possible to do it. And when you make predictions, you need even less hardware because you could use, for example, CPU only. So hardware is good, but of course, the better hardware you have, the faster models will train, the bigger batch you can use, you can make more iterations, and so on and so on. So yes, this is the current situation.
What do you feel about the hardware? Because we have seen hardware which was being influenced by the brain because world is moving more towards the edge neuromorphic, that's for sure, but algorithms are also being influenced by the psychological aspects sometimes, or sometimes wavelet functions which we take the reference of an activation function which is from the wavelet function at the end of the day. But I just wanted to ask you this question particularly to you because you are a kernel grandmaster and you have worked with lot of algorithms. So, what do you feel about the algorithm these days? They're all brute force at the end of the day, but what is that actual difference that you are seeing today with deployment of algorithms and also in production?
I think that machine learning can do really a lot of things, but not always, because at the end of the day, machine learning is a tool which is used to solve some specific problems. And sometimes there are other tools. Sometimes, often there are no other tools than machine learning, but it isn't always good enough. For example, even when we don't have enough data, you now machine learning algorithms will help. It's especially difficult in when you are working on some kind of new and unique problem. Also, it's, for example, if you are working on NLP problems in some less popular languages, then you will hardly find pre-trained models. You will have even just not enough data to pre-train a big model. You will have problems with creating labels, and if you work with some specific domain, chances are there won't be any open data sets, and you will have to collect data by yourself. So you'll spend maybe 80% time on collecting the data and only 10% time of the project on the machine learning itself. Uh, Also, there is another point of view is that still nowadays a lot of people don't trust machine learning models. They prefer their own expertise, their domain expertise. They may say that the models are wrong and you have to prove it. So it's we have progress right now, but still it's we have a long way to go until all people trust machine learning. And also, there are cases when people are correct in not trusting machine learning models because they can be biased. I suppose we all here heard a lot of different scandals about ethics in machine learning. I don't want to debate whether they are correct or not, but there are really many cases when the data used to train machine learning models wasn't good enough, it was not representative, it was biased, and as a result, the predictions of the models aren't good enough and they favor one certain outcome. So I think that machine learning nowadays is an amazing tool. It can do many things amazingly, but we need to work more and making it better.
Yeah, because you told about data sets which are humongous now. So when we take consideration of fields like genomics, proteinomics, and also a lot of stem cell researchers have given their work based on AI. Because of course they were once upon a time not being an AI scientist who never knew what AI was, but they have tried to implement it and they have got groundbreaking results at the end of the day. I just wanted to ask you this one question because world is going behind the trend of AI. will just applying AI for all the problem statement give us that actual optimized solution, or else the desired solution which a scientist really wants, or else what's the madness which is going on in the workflow of AI, which is now the current trend. Probably bioinformatics is in the picture, nuclear engineering is also in the picture, quantum computing is also in the picture. What's that all about? This community workflow of AI.
I think that deep learning and AI in general, if we call it that, will help with many problems if we have enough data. Yes, I talk maybe too much about the data, but I have faced the situations like this and have a lot of friends who had similar problems. So let me repeat. If we, for example, there is medicine, like, right? And imagine that there is some kind of less known language. Well, I won't tell that's less known, but for example, let's take some kind of maybe a language from former USSR, maybe let's take Ukrainian language. There are, I know that there are small number of pre-trained models. So, for example, imagine that you want to do some kind of medical task, maybe you want to do optical recognition character, like you have some written information about people and you want to translate it into text. The problem is that first you need to collect the data, and if you, for example, go to a certain hospital, you could collect the data from the doctors, right? But if you go to another hospital, you will find that they have different forms. Maybe they have people have different handwriting and so on. So you won't be able to apply a single model to every hospital in the country. Yes. Uh, Another possible problem is that. Mm, the people expertise can't be defined very easily. For example, in psychology, I suppose we can't yet make excellent machine learning models because it's very difficult field and we can't all we don't well let's see the people who work there, they can talk with patients and they will be they thanks to their experience they will understand a lot of things and they will be able to come to right conclusions. But our machine learning models will require a lot of data which will be difficult to get to so that good results. But there are many cases when AI will get huge results. I think that the main possible usage of machine learning algorithms is in medicine is when you don't have enough personnel. For example, you have some poor country, you have a lot of people who require medical aid, but you don't have enough people with medical experience, medical education, right? So you may create some good AI model. Maybe it wouldn't be good enough as some excellent experienced doctors, but it will be as good as an average doctor, and it will be able to help thousands and millions of people. So it will be give a cheap access to medical experience, right? So I think that even nowadays, even despite many problems, machine learning AI could help a lot of people in medicine and in more specific domains.
Yeah, because even in medicine, people are trying to deploy the edge computing aspect, because they need a real time solution, because they can't rely on the cloud cluster which is making the decision. What if there is a network glitch and there is an abrupt uh, adversarial attack which can be seen
Yes.
through any one of those functions, which can just handle or just change the way in which the machine is predicting? Because that's what it is all about, because it's all about that accuracy that we are working on. The Jitendra Malik is one of the top-notch professor in the computer vision. He himself says that if you want 99.9% accuracy, work for 5 years.
Yeah.
I just wanted to ask you this one question, because there has been influence by those great people in terms of theory, but also companies are also making lot of influence today. Nvidia bought ARM for $40 billion. That's a whopping amount of money, which actually took industry into a great height, because ARM is one such company which gave out the architecture for the edge computing. Nvidia is the one which actually gave out the video card, the GPU. But what is that all about? What's your view on Nvidia taking over ARM for $40 billion? what do you feel? Is it a waste of money, or else what is the next disruption that we can think about from this combination?
I think we will know maybe in 5 or 10 years because Nvidia certainly had some reasons to pay this money. Maybe at least they had some reasons to buy the company. Maybe they simply gave this money because otherwise RM wouldn't agree to be sold. So I think that there were some reasons, and considering that Nvidia had a lot of success in developing huge video cards and in computing in general, I suppose that they will be able to reap the benefits, but it will take a lot of time to consume such a huge company and to integrate these technologies into their own. So I think that Nvidia will continue to be one of the biggest and strongest companies in this sector in the future. But at the same time, I think that there will be more companies like IRM which will replace it, which will be new players on the market, and maybe thanks to the new open place, we will have some new and even better companies which will compete and create even better solutions in future.
Thank you, Andre, for this amazing podcast. You actually gave a lot and lot of insights on the kernels. You actually gave an actual insight on the hustle which you have to put in when you have a day job and you are a Kaggle grandmaster. And thank you, Andre Lukyanenko, for this amazing podcast. And hopefully, I'm waiting to do one more with you. And I'm also writing a book which is called as the Notebook of an Data Science Enthusiast. And I'll be giving one of the copy to you. Please do review it and just give me that one short review, which I can really feel happy about writing a book, because I've seen you as my hero, and it gives me a very proud feeling of doing a podcast with you virtually. I never got a chance to meet you at the end of the day, but I got the chance to meet you virtually. And thank you so much, Andre, for this amazing opportunity which you gave for me.
Thank you for your kind words. I really enjoy writing kernels and helping people. So I'm glad that I'm really honored that people like my work, because maybe 5 or 6 years ago, when I worked in a different industry, I couldn't even imagine such situation. So I will be sure to write more kernels and help more people in future, and I hope that it will help some people and maybe inspire them to do something even better than me.